What up, mathletes? Whoop, whoop. Ready for part 2 of going through the review. So we're going to factor these. Okay, let's do the generic rectangle and diamond method. Which is z squared first. 26 goes here, negative 15z at the bottom of the diamond. Multiply these together to get the top, 26z squared. And what can I multiply together to get this? Well, negative 13z and negative 2z. Two negatives make a positive. 2 times 13 is 26. Negative 13 minus 2 is negative 15. Oh. Negative 13z and negative 2z. Now, guys, whenever you have a negative in both diagonals, and positives here, we're going to have to do this a little differently. So between z squared and negative 2z, I can pull out a z. But down here, because I don't want my z term to be negative, I have to make this negative. So out of these two, I'm going to pull out a negative 13. And then down here, now, I can just write z, because z times negative 13 is negative 13z, z times z is z squared. And then what times negative 13 is positive 26? Negative 2. So the answer is z minus 13 times z minus 2. All right, let's go ahead and factor this one out. Two x squared minus 14 and 3x down here. Multiply these together and I get negative 28x squared. Which, watch it, 7x times negative 4x. So let's put that in there, 7x. Negative 4x. Between these two, I can pull out a 2x. I can pull out a 7. And 2x squared times x, or 2x times x is 2x squared. And then down here, 7 times negative 2 is negative 14. So I'm left with 2x plus 7 and x minus 2. Last one for this page is going to be a special one, because I noticed this is a perfect square. V is the square root. This is a perfect square. 8 is the square root. Now we got to multiply 2 times v times 8, which equals 16v, and that matches the middle term, which means my answer is, because this is a positive, v plus 8 squared. You're welcome to use the generic rectangle and diamond, but I like those perfect square trinomial shortcuts. Again, I'm assuming you guys are pausing this as we go along. Please do. Let's get into some quadratics and factoring. So looking right here at this graph, guys. First of all, is it opening upward or downward? Clearly downward. Find the x-intercepts. Well, that's right here at x equals negative 3 and x equals negative 1. The y-intercepts clearly, I don't know where it clearly is. Oh, crosses through right here, which is at negative 3, right? Find the coordinates of the vertex. Well, don't forget, remember our little kit from back in the day says our axis of symmetry is the x value of our vertex, right? So because of that, our x value is always negative b over 2a. In this case, I guess we don't have an equation, so that doesn't apply. Forget I did that. I'll leave it in because why not? It's true. We'll talk about it later. But right now, let's just find our vertex. It's this point right here in between the two x-intercepts. So it's going to be at the point negative 2 on the x. And then on the y, it goes up to 1. Boom. Equation of the axis of symmetry. Well, that axis of symmetry is right through the vertex. So it's at x equals negative 2. I guess you can't see that, so sorry. It said x equals negative 2. Okay? Awesome. Remember, pause as needed. Okay, this one right here, y equals x squared is this graph, and we want to translate it to make the graph x squared plus 2. Well, plus 2 on the outside, translate everything up to. So from here, the vertex goes up to 2. But also we see a nice lattice point here. That's going to go up to. Same on this side. It's going to go up 2. And then let's just connect those dots, right? Best of our abilities. Boom. We translated it 2 units up. Now it's asking for domain and range. And really, there's several ways you could answer this, whether using set builder notation, interval notation, just algebraic notation. So domain, first of all, don't forget is x, range is y. Help you remember, x comes before y in the alphabet, so does d come before r. Well, let's see, this is going up, but kind of to the right forever, so it's really going to infinity to the right. Same thing to the left. So x can be a number of things. The domain is all real numbers. Or you could say, if you're doing interval notation, negative infinity to infinity. And you use those round brackets to signify there is no end. It can't equal that end point because there is no end point, right? It's infinity and negative infinity. Or you could say curly brackets, all x, such that x is a real number. End of curly brackets. Right? Those are the 3 ways. Range, same kind of deal, except we see there's a bottom point right here. If we follow it over, that's at 3. So we know that our y has to be greater than or equal to 3. It can equal it because it's right on it, so we know it can equal it. Also, I could say, curly brackets, all y such that y is greater than or equal to 3. Or, I could say, hey, square bracket because it includes the point 3, and then it goes off to positive infinity. It's going up forever, right? So those are possible ways to write those, the domain and range. Sweetness. We are just cruising along, guys. Graph the parabola. Okay, well, let's do a few things. One, we know it's going to open up because this is positive, so it's going to open up. Next, I also know that my y-intercept, I'm actually write this up here, my y-intercept is at 0, -8. Why? Because my y-intercept is always that c value. Let's find our x-intercept. We're going to have to factor this. So I'm just going to turn this into a generic rectangle. I'm going to write right over it. And a diamond problem, and we've got what? X squared minus 8 and negative 2x, negative 8x squared up here. What can I do that with? Well, if I have a negative 4x and a positive 2x, that'll work. So negative 4x, positive 2x. I can pull out an x right here. I can pull out a 2 here. X times 2 is 2x. And negative 4 times x is negative 4x up there. So I know now, and to graph it, we need to write equals 0. And what do I know? I know that I have my x plus 2 and my x minus 4, and I got to set it equal to 0 so I can use the 0 product property, which tells us that one of these has to be 0. So we're going to solve it for both. X plus 2 equals 0 means that x equals negative 2. X minus 4 equals 0 tells me when I add 4 over, x equals 4. Okay, so let's write down our x-intercepts. We've got negative 2, and we've got positive 4. And don't forget my axis of symmetry, right? That middle point in between these two x-intercepts, excuse me, is our negative b over 2a. And if you look up here, my a equals 1, my b equals negative 2, and my c equals negative 8. So I'm going to have negative, my negative b is negative 2, all over 2 times my a value of 1. So this literally equals 2 negatives make a positive, 2 over 2, which equals 1. So if I'm looking for my vertex, don't forget, my vertex has the x value of the axis of symmetry. Then I just plug that in. I end up with, plug it in for x, 1 squared minus 2 times 1 minus 8, which is just 1 minus 2 minus 8, or 1 minus 10, which equals negative 9. And that is the y value, 1, negative 9. So let's go ahead and graph all this. My y-intercept's at 0, negative 8. At 1, negative 9 is, oh, excuse me. Yeah, I did that right. 1, negative 9 is my vertex, and really my axis of symmetry goes right through here, right? Because of that, this is one away. I can draw another dot over here. And let's graph it. Boom. That takes a little work. That's a good problem right there, y'all. Again, positives needed. Okay, and I think right here, I'm going to go ahead and, you know what, let's do one more. Let's do one more. Didn't think you needed my sneezing on video. All right. What is the vertex of the function? Okay. Well, there's lots of ways we can do that. First things first, of function 1, excuse me. The vertex of function 1, well, a equals 2, b equals 16, and c equals 39. And let's see, my negative b over 2a is going to equal negative 16 over 2 times 2, which is negative 16 over 4, or negative 4. So I know that the vertex is going to have negative 4 for an x value. And then let's plug it into the equation. 2 times 4, negative 4 squared, plus 16 times negative 4, plus 39. So what's that going to be? Negative 4 squared, guys, this is 16. So what, positive 16? 2 times 16 is going to be 32. And then 16 times negative 4 is going to be negative 64, and then plus 39. So these right here make negative 32. Negative 32 plus 39 equals 7. So what is the vertex of function 1? Negative 4, 7. What is the vertex of function 2? Well, let's follow it. Notice how it goes. Negative 7, 11, negative 5, 5, negative 3, 3, negative 1, 5. Went back up, which means this is my in-between point, my vertex, negative 3, 3. Which has a smaller minimum value? Well, let's see. This is going up, right? Because it's going up 3, 5, 11 on the y on both sides. This one's positive, so we know it opens up. So let's look at their vertex. The vertex will be their minimum. So negative 4, 7, right? That's up there. And negative 3, 3. That is the smaller value because the y is lower than this y. So it would be function 2. What is the smaller minimum value? Well, it's 3. All right, so smaller minimum value is 3. Perfect. With that said, we're going to go on and we'll finish this in part number 3. Peace out.